क्या म्हटला? नको नको बस कंटिन्यू कर, चालू करतो, चालू झालंय. Hello everyone. So today we are going to go ahead with the next application, that is temperature control using fuzzy knowledge based controller. So FKBC, fuzzy knowledge based controller for temperature control. So this kind of this temperature control can be used for n number of applications. Again, it can be a temperature control for a room. For example, an automatic ACs can be considered, wherein depending upon the environmental condition, depending upon the number of people in the room, depending upon the external conditions such as humidity, air pressure, wind. So depending upon all these parameters, it will adjust the temperature which is required inside the room. So this can be one of the applications. There are different applications wherein, for example, temperature control can be applied for the regular fans also. So depending upon the temperature inside the room, what it will do, it will adjust the speed of the fan. Suppose it is very much hot, automatically the speed of the fan will increase. If it is cold, the temperature inside the room is cold, in that case what it will do, it will reduce the speed of the fan. So this is done completely automatically depending upon the situation. You need not preset. So basically what happens with the actual system, or basically what happens with the conventional system is, we turn on, let us focus on an AC, air condition, wherein what is going to happen is you will be setting the temperature on, let us say 18 degrees Celsius or 20 degrees Celsius. Now what happens, at that moment the temperature was pleasant inside the room, but as the night progresses, what happens, that external temperature goes on decreasing. Suddenly what happens, the temperature inside the room also goes on decreasing very much, which in terms what will happen is we will be start feeling cold. So in order to avoid that thing, depending upon the external temperature, internal temperature, depending upon various parameters, the controller has to take the decision that what should be the appropriate temperature. Suppose that if you select pleasant temperature is between 20 degrees to 24 degrees Celsius. So what it will do is, whatever might be the temperature, it will try to adjust the temperature inside the room at that particular point. But the input to that controller is the parameters such as internal room temperature, external room temperature, then humidity, then what we can say wind velocity, such kind of parameters can be considered, and then it is going to take a decision that what should be the temperature inside the room. So this is what is the temperature control for your temperature control. Now this temperature control needs to be designed, or the controller for this temperature control needs to be designed using a fuzzy logic. Fine. So in order to do this thing, again the same thing, we need to understand, we need to select the input and output parameters. Okay. So our first input parameters, so input parameters are, first, external temperature. External temperature. Second, humidity. Now, then output. What is our required output? Obviously, the required output is the temperature which is there inside the room. So, internal room temperature. Internal room temperature. So this is what is the requirement. So now what we have done, we have selected our input and output parameters. Now the next step, what we have to do, we need to select the range. We cannot design a system for an infinite range. So we have to select our range. What we will do is the external temperature. So external temperature, let us say that if we are talking about the Belgium region, our external temperature varies from between 6 or 7 degrees, which is the coldest temperature which was recorded is something around 6 to 7 degrees Celsius, and the maximum temperature was recorded something around 35 to 40 degrees maximum temperature. But in order to have a broader range, what we can say is we can have a maximum range of a temperature for a system as 0 to 50 degrees Celsius. Now, except few parts of the country, majority of region in the country lies in this range. Okay, there are few regions wherein the temperature in some seasons go below 0 degrees, but if you take an overall view of a country, our maximum range or maximum and minimum range of the country is lying from 50 degrees to 0 degrees. Okay. So this is what is the temperature range what we have selected, and the next one is nothing but the humidity. Now humidity varies with the region. So if we go toward the coastal region, the humidity is high. If we go towards the mountainous region, the humidity is lower. So depending upon the region to region, the humidity goes on varying. So we can say that the minimum humidity is 0% to 100% humidity. These are extreme conditions which will not be possible. So let us just take a range, but 0 to 100 degree, 100% is the humidity. Next, again, room temperature. Now, what is the temperature band which we require always? Let us say again the same thing. We require a temperature band from something around 10 degrees Celsius to 30 degrees Celsius. So if the temperature is something around 50 degrees outside, we will set it to 10 degrees so that the ambient temperature is within in a pleasant manner. Suppose it is 0 degrees, okay, so it is chilling, so we need to increase that room temperature. So we will set it to something around 25 to 30 degrees. So that is the range we have selected it as 10 degrees to 30 degrees Celsius. Okay, so these are the input and output parameters which we have decided. Now the next step is term set. Term set is what again? We need to divide this into few subcategories. As we have already seen in the previous lectures also, we will not be using direct 0 to 50. Instead of saying it direct 0 to 50, we will be dividing into subcategories. Now, let us say that this subcategory. Okay, first what we'll do is we'll draw it and then we'll show you, or let us just show it, no problem. What we can say is, in this case, 0 to 0 to 20, then next is nothing but 10 to 30, and then 20 to 40, 20 to 50, 30 to 50, 10 to 30, 20 to 40, and then 30 to 50. So we can say that external temperature is low, that is L, medium, that is M, and this is high, this is H. So we have categorized it as low, medium and high. It can also be categorized as extremely low, low, medium, then high and very high. So in that case again we will be dividing it into other further categories also again. So but for simplicity reason we have just kept it as low, medium and high. Next is what? Humidity again. So low, this is medium, and then there is a high. So for low, what we can say again, 0 to 30, 0 to 40 we can consider, then 30 to 60, 70, and then 60 to 100. So this is nothing but our categorization for humidity. Next is nothing but our internal temperature. Internal temperature ranging from 10 to 30 degrees. So what we can say is, so again we can categorize it as low, medium and high. This can be done. This can be categorized into pleasant temperature, slightly lower than pleasant, more than pleasant. So something can be nomenclature can be given as anyhow, whichever is feasible at the situation. But for simplicity, as I said, we will be seeking with low, again medium, and then high. So low ka range is what we can say is 10 to 20, then 15 to, sorry, what we can say is 10 to 20, then 15 to 25, and then 20 to 30. So these are the ranges what we have selected now. Now the next step what we need to do is we have to go for fuzzification of these crisp inputs. So let us just do the fuzzification. Okay, so let us just start from this point. So this is temperature T, what we are going to say, mu of T. TE we will set, external temperature. Fine. Now, this is nothing but our 1, maximum degree of membership. So range is 0 to 50 degrees, 0, 10, 20, 30, 40 and 50 degrees. So focusing on these things again, the range what we have selected is 0 to 30 as low. Fine. So what we can say is 30 is 50 here, center will be 15. So 0 to 30. Next, medium is what? 20 to 40. So 20 to 40 is 30 is the peak, I think. 0 to 40. Next is what? 30 to 50. So 30 to 50. So this is low, this is medium, and this is high. So we have done specification for our temperature. Next is nothing but our humidity. Okay. H. This is mu of H. Again the same thing. This is one membership. Range is 0 to 100%. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, and this is 100. So range is 0 to 40. 0 to 40 is basically so we can consider 20 as our center. Next is 30 to 70. 30 to 70. So 50 becomes our center. 30 to 70, and then next is nothing but our 60 to 100. So 60 to 100, what we are going to do? So 60 to 100 is till 90 we will see increasing, and then it will remain constant. Okay. So this is low, this is medium, and this is high. Similarly, it can be followed for this also. We have not considered this thing. What we'll do is we'll change the range here. What we'll do is we'll take it 45. So till 45 it is incremental only, and then after 45 till 50 it is constant 1. So we will choose a different shape of membership instead of going for triangular one, because what happens is what we are saying is high temperature. So 30 degree is having a degree of membership of 0. So as we are approaching towards the 40 degrees, the value goes on increasing. Till 45 again it increases, it reaches its peak value. 45 degree and 50 degree will not make much difference because both are extremely high temperatures. So it should have a degree as 1. We cannot go on decreasing, because what will happen is if we go on decreasing it, it means that the degree of membership is reducing, and it should not reduce, because for high temperature the value should remain as maximum. Okay. So similarly we have done it for humidity also. Okay. And the last one is nothing but our internal temperature. So this is 10 to 20, then 15 to 25, and 20 to 30. These are the ranges what we have selected. We'll just make a note of it, and then we'll draw it now. So the range starts from, let us say 10, 15, 20, 25, and this is 30. Okay. So again the same thing. This is 1, and range for our low is 10 to 20. So we'll consider 15 as our peak. This is low temperature. Then 15 to 25. This is nothing but the second shape, and then 20 to 30. Medium, and this is high. So now what we have done, we have done the specification for our all the input and output parameter. Okay, so we have done the specification for our both input and output parameters. Fine. So the next step is what? Inference engine. Now the type of inference engine which we are using for our calculation is Mandani clip type of inference engine. The same inference engine which we have used for earlier problems also. Now before moving ahead, now the same pattern. What we have to do? we have to design our rule base. So let us just design our rule base. So this is nothing but your humidity and this is your temperature part. So low, medium, high. This is low, medium, high. So now let us just design our rule base, which says that if the temperature is low, and humidity is low, means what? If the external temperature is low and humidity is low, basically what means? It means it is a very chilling temperature, okay, cold temperature. So in that case, what should be your internal temperature? We want it to be high. Next, if the external temperature is medium and humidity is low, in that case we want our temperature to be medium. If the external temperature is high and the humidity is low, we can have our internal temperature to be medium. It can be low also, sometimes it can be medium. We can use medium because in the region like Belgium, we do not have much humidity. Okay, so in that case, you will not be sweating. So in that case, medium temperature will be fine. But if you go for a coastal region, even if the temperatures are high and the humidity is, you have to go for a very low temperatures. Okay. So next thing, temperature is low, humidity is low, we have to go medium. Medium, always medium we will take. And then humidity is high, temperature is high, humidity is medium, we will go for low temperature now. Next, temperature is low, humidity is high, we will go for medium temperature. Humidity medium, high, we will go for high, and this also will be high. Fine. So this is how we have designed our rule base. So basically these are nothing but the if-then rules. For example, we can say for this rule as if the external temperature is low and humidity is low, then the internal temperature is. So this is how we have to design the rule. For example, in this case, if the external temperature is high and humidity is high, then the internal temperature should be, in this case it should be low. By mistake I have written low, because if the external temperature is high, you want the internal temperature to be lower. So if the external temperature is high and the humidity is high, in that case what we want? We want it to be low. Fine. So now the next part of the problem is we need to assume one, or we need to take one example, and then we need to say what should be the value. So let us just take an example now. So the example says that let us assume some data. If the external temperature is something around, let us say 30 degrees Celsius, and let us assume that humidity is something around 40%. Then what will be internal temperature? So this is what we need to find out using fuzzy logic. Now what we will do, again the same thing. Let us come back to the diagram wherein we have to first select the temperature as 30 degrees. So 30 degrees, okay. So 30 degree is lying in all the three parts. So you can see that the range for the low temperature is 0 to 30. So 30 degree is having degree of membership as 0 in category of low. If you take it in the band of medium, what is the value of 30 degree? It is having 1. But if you check it, it is also lying in the high region, that is 30 to 50, wherein this also has a degree of membership of 0. So as we know one thing, we have to always select we have to always select the band wherein it is having the maximum degree of membership. So 30 is having a maximum degree of membership in medium, so that's why it will be selected as medium. So medium is selected in external temperature. So external temperature is medium. Next, when we come to the humidity part, humidity is how much? 40%. So 40% is here. Now 40% is lying in both now two categories, in low category and in medium category. So if I just check with this graph for low, 40% is coming in the band low with a degree of membership of 0. But if you just check it in the range of medium, so it is having a range of, let us say, 0.7. So 40% has a degree of membership of 0 in low category, whereas it has a degree of membership of 0.7 in medium category. So the degree of membership or the highest degree of membership needs to be selected. So in that case, what will happen? It will select it as medium. So now humidity is what? Medium. Now the rule which is getting executed is rule executed. If TE is M and H is M, then TI is M. So this is the one which will be, this is the rule which will get executed. So out of all 9 rules, this rule is getting executed. Now this rule gets executed in the inference engine where all the calculations will be taken place, and then a fuzzy set will be sent to the defuzzification block for further computation. So let us just do the same thing now using Mamdani's clipped inference engine. What we'll do, we'll project it on the output domain. So output domain is what? Medium. It has come on the medium. So medium triangle needs to be selected. But we need to see the where exactly it is getting clipped. So this we are projecting it on this part. So the maximum point is this, and the second 0.7. So this is 0.7. Okay. So now we can see that there is one clipping here and another at this point. So always select the highest clipping point. So in this case, what happens? This is the point. So what will happen is the entire triangle will get selected. So this point will be getting selected. So the entire triangle will get selected, and this will be sent for the defuzzification block. So now let us just see how exactly the defuzzification occurs here. Defuzzification. Now the area which we have taken, so mu of T internal, and this is T. So we have a range which we had been selected as 15 to 25. So 15, 20, and this is 25. So this is the triangle which has been selected. Now, which all techniques are applicable here? So as it is a peak function, so obviously height method is applicable. Second, first of maximum, last of maximum, fourth, center of gravity, COG method. So these 4 methods are applicable. Middle of maximum, weighted average methods are not applicable because they are applicable only for flat functions, and there is no flat function available here. It is a peak function. So these 4 methods are applicable. So according to this height method, what does it do? It will select the highest peak. So highest peak is what? This value, and the value corresponding to this will be 20. So Z star is, that is this defuzzified value according to this. So Z star using height method will be 20 degree Celsius. Next, first of maximum. The first maximum peak, as there is only one peak, the first maximum peak and the last maximum peak will be same. So this value will be selected, and corresponding to this, the defuzzified value will be this one. So 20 degrees will be again defuzzified. So this also 20 degrees. Now in case of a center of gravity method, we need to apply our method. So let us say A, B and C. So we have to use our formula Z star is equal to integration of mu of Z into Z dz divided by integration of mu of Z dz. So this has to be applied. So using our straight line equation and all those things which we have seen in the earlier classes, what we need to do is we have to select find out for this area, and then substitute this in the equation and find out the center of this area. Now as it is a symmetric triangle, obviously the center of this area will be what? This point. So again obviously it becomes 20. So after solving all those things, you will be getting 20 degrees Celsius as your answer. So you can see that all the methods are giving you the same result. Thus what we can say here is, if the temperature, the conclusion part is, if the temperature is 30 degrees Celsius, external temperature is 30 degrees Celsius and the humidity is 40%, then the internal temperature of the room needs to be 20 degrees. So in order to have this 20 degrees, what it will do, controller will find out the fan speed and all some calculations will be done, and it will adjust the AC to 20 degrees such that the internal temperature of the room becomes 20 degrees. Okay, so this is how the entire system works. So this is nothing but the fuzzy knowledge based controller for controlling the temperature of a AC. Clear? So this is nothing but FKBC for temperature control. Okay, thank you everyone.